Hello, 8-bit physics students. Mr. Curson coming at you here. Today we're going to talk about a little resistance and resistivity. Starting with chapter 18, problem number 13, plus an extra little bonus video hint for you on problem 26. Okay, problem 13 asks, I got a wire, and the wire is 3.5 meters long. It's made out of the element copper. Its diameter D is 1.5 millimeters. What is the resistance of this wire? So we could hook up a voltmeter and a current meter and use Ohm's law to figure this out. Or we're going to find out today we can just use the geometry and the material to figure out the resistance of this wire. Or you can figure out the resistance of many materials this way. And here is the formula we're going to use. It's a new one. So the resistance of a piece of material is equal to the resistivity of that material times its length divided by the cross-sectional area A. So the new thing here that we're going to be talking about is the resistivity of a substance. So here this looks like a P, but it's not a P, it's actually the Greek letter rho. So the Greek letter rho represents the resistivity of a material, and it is measured in ohm meters. Okay? So the resistivity of a material. Now, there's a nice table in your book that will tell you here, this is page 501, that the resistivity of copper here is 1.68 times 10 to the minus 8 ohm meters. Notice that conductors have very low resistivities, and insulators have very high resistivities, and semiconductors are somewhere in the middle. Something I always thought was interesting here, copper has a lower resistivity than gold. But yet, every once in a while in a speaker store or something, you'll see people selling gold-plated speaker wire or something, which actually would increase the resistance of the wire. Okay, so rho is the resistivity, and it's a property of a material, whereas resistance is a property of just, a certain chunk of material or a certain object. So from the book there, we saw that the resistivity of copper is 1.68 times 10 to the minus 8th ohm meters. So why don't we take that information here and plug it in up over here, and we would get that the resistance of this chunk, you guys can't see this, okay? The resistance of this chunk of wire would be 1.68 times 10 to the minus 8, the resistivity of the copper, times the length of the wire, which would be 3.5 meters, divided by the cross-sectional area. So to get the area here, we would want to do pi r squared. Now, since this is in meters, this is ohm meters, we would want the area, pi r squared, also to be in ohm meters. So what I'm going to do here is I'm going to convert this millimeters here into meters, right? 1.5 millimeters, 0.0015 meters. Divide that by 2 to get the radius, since the area would be pi r squared. And if we plug all that in, we would get a resistance of 0.033 ohms, or about 3/100ths of an ohm, which makes sense that this resistance would be quite small. It's a conducting wire. It's a wire used to conduct electricity. If you remember yesterday in our problem, we had a hairdryer with a certain voltage, and the resistance of the hairdryer was 16 ohms. but we did not take into account the resistance of the wires, which is probably a good assumption, right? If you're talking 16 ohms and these wires are 0.03 ohms, unless you're going to four significant figures, you can call the resistance of most wires zeros if you're dealing with something big like 16 ohms, all right? Okay, well, I hope that helped. I'm going to give you some hints here on problem number 26. And I'm not going to do the problem, but I'm just going to explain the formula you're going to use to solve the problem. We've talked about power before. Power is the rate at which you do work. Power is measured in watts. And when you're dealing with electric circuits, power can be measured by current times voltage. So remember that power should be measured in watts, right? And does this make sense? Well, what is current? Current is in coulombs per second, right? What is voltage? Voltage is 1 volt is 1 joule per coulomb. So this turns out to be joules per second, because coulombs cancels, and is the units for watts indeed joules per second? That is correct. So just an example, that 60-watt light bulb that's in your house that is plugged into a 120 volt outlet, you would be able to tell me that the current in that going through that 60-watt bulb is about 0.5 amps, right? Just as a little example of how to do that. But I will let you tackle problem 26 on your own. As a hint, you are going to use this formula here. For your joke today, all right, I got one that goes along with this. All right, are you ready? Okay, here we go. Why do cowboys prefer to use an electric range? Because they like to feel ohm on the range. Get it? I should have said an electric stove instead of electric range. That would have been funnier. But anyway, all right, nice work, AP Physics students. We'll see you tomorrow.